Hi, welcome to my second video on calculus in the playlist of UPSC Max Optional. Now, in the last video, I gave the overview of the syllabus from calculus. That is, in the last video, we saw the overview of this syllabus. So, as I said earlier, I am going to start with limits, and then after finishing limits, I'll move on to indeterminate forms because these two are interlinked. So we are going to solve problems based on limits and indeterminate forms. So in the description I have gave you a link for the introduction to limits. So you kindly watch that video before getting to this video. So you can see the link in the description, which I will talk about what is meant by limit and how to find the limit. Now in this video we are going to solve problems based on limits, and then we will move on to indeterminate forms. Now, so you kindly pause the video and then you go to that video and watch that video and come back here. Now I hope you have watched that video. Now we are getting into the problems based on limits and indeterminate forms. So after finishing limits and indeterminate forms, we will move on to continuity, differentiability, and then so on. So first is limits and indeterminate forms. So if you have watched the videos in the description, you come to know that limit exists if the left hand limit and the right hand limit exist and both should be equal. So the left hand limit we should find by limit s tends to 0 f of a minus s, and right hand limit we should find by limit s tends to 0 f of a plus h. If both LHL and RHL, so LHL stands for left hand limit and RHL stands for right hand limit, if both exist and finite, then if both exist and finite if they are equal, then we say that the limit exists and it is equal to the value which they are equal. Now I am going to solve lots of problems based on limits and indeterminate forms. So this is the way which I am going to do. First I am going to solve 7 problems based on limits. The first 4 problems which I am going to do is I am going to find LHL and the RHL, and I am going to see if both LHL and RHL are equal. If it is equal, we say that the limit exists. And the 5th and 5, 6, 7 I am going to do it by theory. So the 5, 6, 7 problems are important, and then we will move on to the indeterminate forms. So there are 5 indeterminate forms. Suppose when we try to apply limit, when the numerator and denominator becomes 0 by 0. Suppose when we try to apply the limit, for example, if we take a function f of x equal to, suppose for example, let me take here. Now consider for example, suppose if you have a function like this, limit x tends to 1, x minus 1 by x square minus 1 by x minus 1. So what happens if I substitute x is equal to 1? So if I substitute x is equal to 1, it will become 1 square minus 1 by 1 minus 1, which will become 0 by 0. So suppose when we are trying to apply the limit, and if the numerator and denominator become 0 and both become 0, we will call that as 0 by 0 form. So how to solve 0 by 0 form? So this is the first, the indeterminate form 0 by 0. So we are going to see how to solve when the numerator and denominator becomes 0 by 0. So the first form is 0 by 0. So there are almost 16 problems on the indeterminate forms first type, which is 0 by 0. You can see here the 14th question is asked in UPSC. And then the second indeterminate form is infinity by infinity. So infinity by infinity, suppose when you try to apply the limit, when the numerator denominator becomes infinity by infinity. For example, let us say let limit x tends to 0, limit x tends to 0, 1 by x by 1 by x square. This will become 1 by 0 by 1 by 0. 1 by 0 is infinity. So this will become infinity by infinity. Suppose when you try to apply the limit, if the numerator and denominator becomes infinity, we'll call that as type 2, which is infinity by infinity. So we're going to solve problems how to find the solution, how to find the limit when the numerator and denominator becomes infinity by infinity, that is type 2. And then type 3, the indeterminate form, 0 into infinity. So when we try to apply here, it will become 0 and log 0 is infinity. So 0 into infinity. So how we will find the limit when we have the form 0 into infinity. So that is the type 3 indeterminate form. And the type 4 indeterminate form is infinity. Suppose when you try to apply the limit when we have infinity minus infinity or infinity plus infinity, so you try to apply limit x tends to 2 here, this will become 1 by 2 minus 2, which is 1 by 0. So this will become 1 by 0. This will become log 2 minus 1 is log 1, again log 1 is 0. So 1 by 0 is infinity, 1 by log 1 is again infinity. So infinity minus infinity. So we are going to find the solution, or we are going to find the limit when the problems became infinity minus infinity. And then the last indeterminate form is 0 power 0, 1 power infinity, or infinity power 0. Suppose when you try to apply the limit when you have powers, so in the form in the first 4 form we don't have any powers. It is very rare, but in the 5th form you will always have a power. So when you try to apply a here, it will have a minus a will be 0, and again in the power a minus a, so it will become 0 power 0. Again if I substitute x is equal to 0 here, cos 0 will be 1, and then 1 power 1 by 0 will be infinity. So I have 1 power infinity. So the 5th form is mainly based on how to find the limit when we have in the form 0 power 0, 1 power infinity, and infinity power 0. So this is the overview for the next 5 to 6 videos. So the next 5 to 6 videos will be based, I'm going to solve all the problems based on limits and indeterminate forms. So this is very important. You can see here almost from every type there is one question in UPSC. These are the questions which asked previous years. So if you solve all these problems, you will be thorough with any type. So you will be able to identify any type of problem and you can solve in your own. So after solving all these problems, I will give some exercise problems so that you will work out and you will get thorough. Now the first problems are limits. So the first 4 problems are actually this is 5th problem, I made some mistake. This is 5th problem, sorry, this is 4th problem, this is 5th, and then 6th and 7th and 8th. So the first 5 problem is mainly based on, I'm going to find LHL and the RHL, and if I'm going to verify whether both are equal. If they are equal, I'm going to call that as limit. Now we'll move on to the first problem. So, and again as I said earlier, so if you have watched the video in the description, you come to know that the limit exists when the left hand limit and the right hand limit exist finite and both should be equal. So this is the formula for left hand limit, which is f of a minus h, and RHL is f. Now the first problem is limit x tends to a, x square minus a square by x minus a. So you change here, this x tends to a, it is not x tends to 0, so x tends to a. So when you look at here, you can use, if you apply x is equal to a here, then I have a square minus a square by a minus a. So this will become 0 by 0. So you can also solve by indeterminate form, or you can also solve by left hand limit and right hand limit. Since we have not solved any problems on the indeterminate form, so we first solve all the 8 problems using LHL and RHL, and then we will move on to the indeterminate form. So a single problem can be solved in many ways. So first we are going to solve the set of problems using left hand limit and the right hand limit. So the first 5 problems I am going to solve is by using the left hand limit and the right hand limit. You can also solve using indeterminate form, but we are going to move steadily. So first 5 problem will be on left hand limit and the right hand limit. So Again the left hand limit. So you know that limit x tends to a f of x is equal to, this limit exists and it is equal to the left hand limit and the right hand limit if two of them are equal. That is, this limit, if LHL is same as RHL, then this limit is the limit of this function. Now we need to find the left hand limit and the right hand limit. So the formula for left hand limit is limit s tends to 0 f of a minus h. Now when you look at this question, limit x tends to a here, so a will be a it is. Suppose if I have limit x tends to 0, then a will be 0. Suppose if I have limit x tends to 2, a will be 2 here, right? But here a is a, so f of a minus h. So limit, so f of x is here, f of x is x square minus a square by x minus a, and a is a. So we should find limit s tends to 0 f of a minus h. So in place of x we need to substitute a minus h. So this will become a minus h whole square minus a square by a minus h minus a. So this will be equal to a square minus 2ab plus b square. So I am applying the formula a minus b whole square. So in place of b I have h. So minus a square by a minus h minus e. So this will get cancelled. This will get cancelled. So I have minus 2ah. Actually I have limit s tends to 0 here. Limit s tends to 0 minus 2ah plus h square by minus h. So if I take I'll take first h common here. So limit s tends to 0. So if I take minus h common here, this will be 2a minus h by h. So this h and this h will get cancelled. Now as s tends to 0, as limit s tends to 0, or if I take minus h common here, I have 2a minus h by minus h. So this minus h and minus h will cancel. So I have left with limit s tends to 0 2a minus h. As s tends to 0, this will become 2a minus 0. So I have 2a. So the left hand limit is 2a, and then I need to find right hand limit. So limit s tends to 0 f of a plus h. So in place of x I need to substitute a plus h. So this will become limit s tends to 0 a plus h whole square minus a square by a plus h minus a. So this will be equal to a square plus 2ab plus b square. So in place of b I have h. So minus a square by a plus h minus a. So this 2 will get cancelled. This 2 will get cancelled. So if I take h common here, I have 2a plus h by h. So this h will get cancelled. So the limit s tends to 0, 2a plus h will become 2a plus 0, which is again 2a. So we see that the left hand limit is equal to the right hand limit, and both are equal to 2a. So therefore the limit of this function is equal to 2a. So this is how to find the limit of the function. Now we'll move on to the second problem. So we have finished the first problem, which is limit x tends to a x square minus a square by x minus a. Now the second problem is limit x tends to 0. Now the second problem is limit x tends to 0 sine 1 by x. Now if I compare with limit x tends to a f of x, so I have f of x is equal to sine 1 by x and a is equal to 0 here. So in the previous sum I have a is a, but here I have a is equal to 0. So first we will find the left hand limit, so which is f of a minus h. So limit s tends to 0 f of a minus h. So limit s tends to 0 f of a minus h. So in place of h, I have substitute f of a minus h. Since a is 0, this will become limit s tends to 0 sine minus 1 by h. So since a is 0, I am substituting a is equal to 0 here. Now we know that sine of minus x is minus sine x. Sine of minus x is minus sine x. So this will be equal to limit s tends to 0 sine 1 by h. Now in the previous video, I have talked about the graph for sine function. So the graph for sine function always takes the value between minus 1 and 1. So this value will be always between minus 1 to 1. So we cannot have a single value. For this, the sine 1 by h oscillates. So sine 1 by h oscillates. So it oscillates between minus 1 to 1. So we cannot have a single limit here. So therefore limit does not exist for left hand limit. Right? So limit does not exist for sine 1 by x. So again, since the left hand limit does not exist, for the existence of limit, both the left hand limit and the right hand limit exist and it should be equal. But since here the left hand limit does not exist, so limit does not exist for this function. So second problem. Now we are going to the third problem. So third problem is limit x tends to 0 x times sine 1 by x. Now here f of x is x sine 1 by x and a is 0. So the left hand limit LHL will be limit s tends to 0 f of a minus h. So since a is 0, I have limit s tends to 0 f of 0 minus h. So this is limit s tends to 0 f of minus h. So in place of x, I need to substitute minus h. So this will become minus h sine minus 1 by h. So sine of minus x is minus sine x. So this will become plus h sine 1 by h. Now as limit s tends to 0, this will become 0 into a quantity between minus 1 and 1. Here I don't have h here, but here I have 0 into a quantity between minus 1 and 1. So it will be 0 again. So look at carefully. Here the limit does not exist, but here I have h into sine 1 by h. So 0 into any quantity between minus 1 to 1 will be 0 again. But here I have only a quantity between minus 1 to 1. So you should know the difference between the x sine 1 by x and sine 1 by x. So again RHS limit s tends to 0 f of a plus h. So this will be limit s tends to 0 f of a plus h will be, since a is 0, I have 0 plus h. So limit s tends to 0 f of h. So limit s tends to 0 f of h will be limit s tends to 0 h sine 1 by h. Again the same reason, 0 into a quantity between minus 1 and 1 will be 0. So again left hand limit and the right hand limit both exist and it's both equal to 0. So therefore the limit x tends to 0 x sine 1 by x will be 0. Now we have solved the third problem. So we are going to the fourth problem, which is the last problem in this video. We want to find the limit of the fourth problem. So limit x tends to 0 e power 1 by x by e power 1 by x plus 1. So you should know the property, some property of e exponential. So e power 0 is 1 and e power minus infinity is 0, and e will always be a non-negative. The value of e power will always be a non-negative number. Now here f of x is e power 1 by x by e power 1 by x plus 1. A is 0 here because limit x tends to a f of x. You need to compare with limit x tends to a f of x. So I have a is equal to 0 and f of x is equal to e power 1 by x by e power 1 by x plus 1. First I will find the left hand limit. So left hand limit is limit s tends to 0 f of a minus h. So this will become limit s tends to 0. Since a is 0, I have 0 minus h. So which is same as limit s tends to 0 f of minus h. So this is equal to limit s to 0. In place of x, I need to substitute minus h. So this will become e power minus 1 by h by e power minus 1 by h plus 1. So if I substitute h is equal to 0 here, this will become e power minus 1 by 0 by e power minus 1 by 0 plus 1. So this is equal to e power 1 by 0 is infinity. So e power minus infinity by e power minus infinity plus 1. Since e power minus infinity is 0, I have 0 by 0 plus 1, which is 0 by 1, which is 0. So the left hand limit exists and it is equal to 0. Now we will find the right hand limit. So the right hand limit is RHL. So limit s tends to 0 f of a plus h. So limit s tends to 0 f of a is 0. I have 0 plus h. So limit s tends to 0 f of h. So f of h. So limit s tends to 0 f of h e power 1 by h by e power 1 by h plus 1. So as s tends to 0, I have e power infinity by e power infinity plus 1. Because s tends to 0, this will become 1 by 0, which is infinity. Here 1 by 0, which is infinity plus 1. You note carefully, e power minus infinity is 0, but e power infinity is infinity. So I have infinity by infinity plus 1. So which means infinity, that means RHL does not exist. So LHL exists, but the RHL does not exist. So therefore LHL is not equal to RHL. So therefore limit x tends to 0 e power 1 by x by e power 1 by x plus 1 does not exist. So we have solved the first 4 problems, and now the fifth problem is find limit x tends to a f of x, where f of x is equal to x square minus a by a, x square by a minus a if 0 is less than x less than a, and 0 of x is equal to a, and a minus a cube by x square if x greater than a. So I have f of x to be, now this is 0 here, when it is equal to a. So I have 3 cases. So when x is equal to a, then I have 0. When x is less than 0, that is 0 is when x lies between 0 to a, it will be x square minus a by a, and if it is greater than a, it will be a minus a cube by x square. Now this is a. When it is 0 is less than x is less than a, the function will be x square by a minus a. When it is greater than a, so this is a here. When it is less than a, the function will be x square minus a minus x square by a minus a. When it is greater than a, the function will be a minus a cube by x square. When it is equal to a, the function will be 0. You have to find the limit. Now look at here, the left hand limit. So limit s tends to 0 f of a minus h. So here a, if I subtract a quantity, it will be the quantity will be somewhere around here. Alright, this is a. If I subtract a quantity h, it will be in the left hand side. And when the function is in left hand side, the function will be x square by a minus a. So in place of x, you need to substitute a minus h. So I have a minus h whole square by a minus a. So by simple simplification, so a square minus 2ah plus a square, which is a minus b whole square formula. So if I substitute, if I take h common here, then I have h times minus 2a plus h by a. So if I substitute h is equal to 0 here, the numerator will be 0, but the denominator will be a. So 0 by a will be 0. Now you find the right hand limit. So f of a plus h. So if I add a quantity from a plus h will be here. So when the function is in the right hand side of a, the function is a minus a cube by x square. So in place of x, I need to substitute a plus h. So again by simple calculation I come to know that the right hand limit is 0. So both the left hand limit and the right hand limit exist and both equal to 0. So therefore the limit of the function at x is equal to a is 0. So we have solved first 5 problems which is based on finding the left hand limit and the right hand limit. Now in the next video we will solve the problems based on theory. So the 6th, 7th, 8th question will be theory questions. So these 6, 7, 8 are important questions. So important limits you need to know, and then we will move on to the indeterminate forms. The indeterminate forms is very interesting. It will be very interesting to solve the problems because we will be using lots of trigonometric ratios and formulas. So in the next video we will solve 6th, 7th, 8th problem, and then in the next video we will move on to the indeterminate forms. So I hope you enjoyed this video. We'll see you in the next video. Goodbye. Thank you.